Welcome to the Formal Logic videos. I'm Scott Aikin. You're you. Here we're doing logic. It's going to be awesome. Now's the second video for logic basics. I'm going to talk about logic as a meta-language. Going to talk about the three questions you ask when asking questions about arguments. I'm going to be talking about types of support that you can detect internal to those arguments. We'll talk about soundness and questions with regards to arguments. And then we'll look at two tests for what's called validity, a syntactic test and a semantic test. Let's get going. So logic as a meta-language. What's meta-language? Kind of know what logic is. It's this sort of discipline that detects and explains when reasoning is good and when reasoning is not good. So the two objectives behind the logical program. But how is it a meta-language? Well, here's the basic way to kind of think about it. Whenever you reason about stuff, you're generally reasoning about things that aren't your reasoning. You're reasoning about cats, you're reasoning about where your friend is, you're reasoning about lunch, you're reasoning about the gross national product of Finland, you're reasoning about all sorts of stuff. That's, you might say, reasoning in the object language. It takes objects, and the objects are stuff. And what logic does is it's about how we reason about stuff. So we think about stuff. What logic is us thinking about our thinking. Thinking about how we reason it out and talk it out. So you might say you've got language, and then what a meta-language is about the thing. So bugs and lunch and Finland. Language is about those things. What a meta-language is about the language and also about how the language does the stuff about those things. So you already speak a meta-language. You speak probably a couple of them. One of them is the meta-language of grammar. Grammar is a meta-language. So whenever you have a well-formed sentence like this is my hand, that's a well-formed English sentence. And what grammar does is it says the word hand is a noun. We're not saying the hand is a noun. We're saying that the word hand is a noun. So we're no longer looking, so I can say it's like, this is my hand, this is my foot. Can't get it up, but this is my hand, this is my piece of chalk. Those are piece of chalk. The chalk is another noun. But this is my hand, this is my chalk. Those are roughly the same kind of sentence, but they're about different stuff. And the concepts that make up those, us being able to identify those sentences is roughly the same in terms of their form and in terms of the way that they're saying things, requires us to kind of have a meta-language. For us to be able to say, okay, look, there's a certain kind of pattern that these two sentences have, and they're effectively grammatically identical despite the fact that they're about different kinds of things. Well, the same thing goes with another meta-language that you speak. You speak the meta-language of literary criticism. So whenever you write a poem about spider webs and rainbows and flowers or whatever your poem's about. But when you do literary criticism, you talk about rhyme schemes. You talk about imagery. You talk about metaphors. And what those are is it's a language about how you did the poetry and about how those metaphors can show up all sorts of places, or how the rhyme scheme can be repeated despite the fact that at one time the rhyme is about a spider web, and then later on it's about some dew or something like that. So you already speak meta-languages. And you kind of see how we do this, you might call it semantic assent. We've got our ground level languages, or object languages, which are about stuff that's not language. Cats and dogs and things like that. What the meta-language does is it talks about the language. It doesn't talk about what the language talks about, it talks about the language. And what it tries to do, and what these meta-languages all try to do, is try to describe those languages and try to describe the norms in those languages. And why the norms are the way they are, and to be able to distinguish between instances of the usage of those languages that are good instances of those norms, or instantiate those norms, follow the norms, follow the rules, and ones that don't. So if I say, this is my hand, that's a well-formed English sentence. If I say, this are my hand, I have, again, in the meta-language, I have a noun-verb failure of agreement, right? The verb isn't properly matching with the noun. So this are my hand, not quite right. These are my hands is right. So what's crucial then is that we can then be able to make distinctions and make corrections at the meta-language level that we wouldn't otherwise be able to make if we were just using the object language. Here's a very simple example, again in grammar. Once my daughter said, Isla and me are going to the mall. And I said, no, Isla and I are going to the mall. And she says, you don't like the mall, Daddy. Get it? That's a confusion of levels there. She took me to be correcting her on the object level, as though I were speaking about her, her friend, and myself, and the mall. But I was talking instead, not at the object level, but at the language level. I was correcting the use of language. I was saying the correct way to say that Madeline and Isla are going to the mall is to say, coming out of Madeline's mouth, Isla and I are going to the mall. Pretty cool, but the crucial thing is to see that logic is doing the same kind of thing. What we're doing is we're coming up and we're not looking at what we're reasoning about, we're looking at how we reason about what we reason about. So, logic's a meta-language. And we do that, again, by coming up and looking at these multiply repeatable forms and explaining why those forms work. Now, anytime that you're reasoning about reasoning, you really need to ask yourself three questions. So, arguments are generally posed to audiences, and generally the question here is, if you're a member of the audience, or if you're watching an argument go down, you ask yourself three questions. Again, arguments are collections of propositions with two subsets, premises and conclusions. They've got that functional relation of premises being the grounds for reasons for accepting the conclusion. So you ask three questions. What's called the material question, the question of the logical question, or the question of logical success, and the question of rhetorical success. So the material question is, are the premises true? Do I like these premises? Do these premises look right to me? So you ask the question, are the premises true? The question of logic is a separate kind of question. And here's a very simple example, which is that I can give you true premises that have nothing to do with the conclusion. So for example, let's say that I need you to believe that the earth is flat. And you say, well, give me an argument. And I say, this is my hand. Say, but the problem with that argument isn't that it's got false premises. It's got a true premise. The problem is that the premise has nothing to do with the conclusion. It's not entirely clear how that premise relates at all to that conclusion. That's not a material failure. That's a logical failure. So, the question is, do the premises support the conclusion? Last is the rhetorical question, or the question of rhetorical success. And that's the question, did the argument convince its audience of the conclusion? And so, audience acceptance. And so, one of the crucial things to realize about asking, you might say, the critical questions about argument are the premises true? If the premises are true, do they support the conclusion? And last, did the audience accept it? And so sometimes you ask that question in the first person, did I get moved by that argument? And the explanation for you being moved by that argument should only be on the basis of you saying the premises are true and the premises support the conclusion. Now what's important is that you ask these questions in the right order. Because critical thinking is asking these two questions first. Are the premises true? Do the premises support the conclusion? Then you say, yeah. If I say yes to both of those, I should say yes to the last one. Say, I'm moved. Now, we ask this often in the third person too. We ask the question, why were these people moved by this argument? And from that, we then are able to infer that they did think that the premises were true, and we did think that they thought that the premises supported the conclusion. And so we can criticize arguments that people think are good on the basis of the fact that they were just wrong about those support relations or whether or not their premises were true. Okay, so 3 questions. What we're going to be focusing on exclusively in this class is the logical success of arguments. The materials question of success is the question of whether or not the premises are true. That's not the domain of logic. Identifying whether or not premises are true has nothing to do with logic. That has to do with what the world's like. What logic is about is trying to figure out how we reason to the truth. And so what we're trying to do is divorce the question of whether or not the inputs are good from whether or not we'll just treat the inputs as though they're good and see if they get us to where they promised that they were going to get us. So testing support is just saying something like, look, I will give you your premises. You say whatever you want, and I'm going to see if what you said gets us to the conclusion that you promised us to get. And those are 2 separate ways to criticize an argument. Saying, I'm not going to give you your starting points is one way to disagree with an argument. And then to say, I'll give you your starting points, but I'm going to show that they don't give you the conclusion is another way to criticize an argument. We're just going to be looking at this one. Right? That's the logical criticism. The other criticism is material criticism, and that's just, you might say, disagreeing with premises. Okay? So we're going to be just looking at how premises support conclusions. Again, arguments are supposed to be this functional relation between premises and conclusions. And so what we're looking is just at that functional relation between what we reason from and what we reason to. So we got the 3 questions. Now we've got 2 ways that premises can support the conclusion. On the one hand, we have what's called inductive support. And what's inductive support? Inductive support is if the premises are true, the conclusion is more likely true than false. So the premises make the conclusion more likely true than false. That's pretty much it. And notice, by the way, that inductive support can start at like a probability of just a hair over 0.5 all the way up to a probability of 100% or 1. And notice, by the way, that as a consequence, inductive support is gradable. It can be really relatively weak, just better than chance, to very, very strong, almost a perfect guarantee. And what that is called is strength. Inductive strength, again, is variable. It comes in all sorts of, it kind of ramp from just better than chance all the way up to pretty much a lock certainty. The second kind of support, and the support that we're going to be looking at specifically in this class, is deductive support. Now, deductive support is support that's the following promise. If the premises are true, it is not possible for the conclusion to come out as false. So the truth of the premises guarantee the truth of the conclusion. Now, that doesn't mean the conclusion is guaranteed to be true. The conclusion is guaranteed to be true if the premises are true. Again, we're not taking a stand on whether or not the premises are true. We're just saying that the premises, if they're true, guarantee that the conclusion's true. That there are no instances where the premises are true and the conclusion is false. What arguments of this very, very strong support relation are called valid. Ones that satisfy that requirement are called valid. It's not possible for the premises to be true and the conclusion to be false. Now, how we test for that, so the crucial thing is that we're going to be really just looking at that property. It's trying to find, detect, identify arguments that have got that property. And so whenever we're looking at any of these arguments, this is our target property. Validity is the target property we're looking for. And so what we're going to be trying to do is arrange a lot of tools for us to be able to detect it. And again, recall also that logic is doing a second thing. Explain how those arguments are valid. Recall that validity is a really strong promise. I guarantee that the premises give you the conclusion, that there are no instances where the premises are true and the conclusion's false. So that guarantee is a very strong one. How can you guarantee stuff? That kind of guarantee, that very strong guarantee, requires that you have thought about and be able to survey every possible circumstance. How can you do that? How can you make that kind of guarantee? That is the challenge of logic. That is the challenge of the formal logic that we're going to be learning. Being able to articulate how we're able to make that kind of guarantee and say that this is not just good reasoning, this is in fact a certain kind of perfected reasoning. It's A+ reasoning. It's the gold standard of reasoning. Logical validity is awesome. Now, recall that so far these kinds of support are, you might say, conditional. That they say if the premises are true, then inductive strength, the conclusions are more likely true than false, or the conclusion can't come out as false, right? If the premises are true, then the conclusion's got to be true. Those two kinds of support are again conditional, which is that they're conditioned on the premises being true. So if the premises are true, then you get this transmission to the conclusion. So there's a very important sort of coming together of the truth of the premises and validity. That's whenever you'd say, if the premises are true, then the conclusion's guaranteed to be true, and the premises are true. Arguments of that kind of quality, that right there is the gold standard of argumentative quality. That's the height. That's called soundness. A sound argument is valid. It's valid and it has true premises. So what's important then to see, and maybe like a little diagram will help us visualize it, is that you have valid arguments, and sound arguments are a kind of subset of valid arguments. You have valid arguments, and then you can have valid arguments that have false premises. A subset of valid arguments are valid, and they have true premises. And that's this kind of the gold standard for argument. Now again, with formal logic, we're just detecting what goes inside the bigger circle. What goes inside the smaller circle is not up to logic. That's up to how the world's set up. So logicians don't take a stand on how that works. We do take a stand on how logical validity is identified. So we've got a couple important concepts: inductive support, inductive strength, deductive validity, and deductive support. Finally, you might say the culmination of good argumentative support and true premises, and in this not just good argumentative support, but logical support that amounts to deductive validity and true premises. That comes together to be soundness. Now, the crucial thing with the way that we're going to be learning formal logic is that really there are sort of two parallel running programs internal to any formal logic. And on the one hand, there's the program of what's called semantics, and then on the other hand, there's a program of what's called syntax. And here's a basic way to kind of understand how the two programs work in parallel, and then I'll give you some definitions, okay? So if I say all cats are mammals, Luna is a cat, so Luna is a mammal, what I'd like for you to do is be able to say, like, look, it's really, really clear that on the one hand, the premises are acceptable depends on, the definition of what cat is. The second premise depends on whether or not Luna really is a cat. But assuming that these two premises are true, that conclusion is going to come out as true. And there are no instances where that's going to be false. That's really great deductively valid reasoning. This is an instance of what's sometimes called a syllogism, which is an instance of excellent deductive reasoning. Now, one of the things to see about this is that imagine again that someone says, well, I'm not so sure about this. Like, how's this work? Like, what's going on here? And again, what we do with logic is we don't just say it again, right? Someone's like, hey, I'm not following. How's this work? And you just don't say it. Like, if you don't have a way to come up and say, here's how you're not seeing it. Here, I need to be able to explain it. Otherwise, we would just say it again, or like say it like we're talking to some stupid people. You'd be like, all cats are mad. All cats, right? The crucial thing is that we need to be able to have a semantics, to be able to say, it's clear that there's a word that we're reasoning around that's doing a lot of work. And it's doing so much work here that we need to have a theory about how that word is doing this work, right? And that theory then will be able to not just allow us to identify that this is good reasoning. In some ways, we don't really need a theory to explain, to tell me that this is good reasoning. I don't need a theory for that. I just see it. But I need to be able to do more. Because just seeing it, I just see it. It's just obvious. Well, you know what? There are too many folks out there. Too many folks out there for whom what's obvious for you isn't obvious for them. And the same thing goes for you. Have you ever had someone just say, it's obvious, man? And you're like, I don't get it. And you're like, well, now I'm just going to talk to you like you're an idiot. Turns out that idiots can talk to you like you're an idiot also. What we need is to be able to come up, pull up, and be able to say, hold up. It's clear that this word is doing something. And it's because this word means something. All means all. Well, what the fuck does that mean? How explain it? How in the world was that explanatory of anything? All means all. What's that doing? What are we doing whenever we say all? What we need is a semantics, a story of what that word means, and then that can explain why this is a piece of good reasoning, and while all of the other types of reasoning that look kind of like this, but all the other tokens of this are good. And the same thing goes with this. So again, your friend's at the bar or at home, not at the bar, so at home. In this instance too, we see that in this regard, it's not just one term, but it's these two. Or and not have got a kind of a magic that happens when you put or this and not this, so this. There's a kind of a magic that happens between not and or. And it's because or means what it means. This or this. And again, right now it feels like all we can do is just say it in a weird different tone of voice to say, pay attention to the meaning of this word, but we can't explain what it means. What logical semantics does is it tells us, and it allows us a meta language to be able to explain what these words mean so that we can explain systematically why this is a good piece of inference, why this is a good inference, and many, many more. We're going to have theories about what these little particle-y words, between all the other stuff that we talk about, means. And how they mean then give us a theory of how these forms are good pieces of reasoning. Additionally, our theory of how they mean allow us to be able to string them all together and make them systematic so that they work together as a team. Okay, so that's the big insight behind them. And notice also that because they are repeatable, it looks like once we see the pattern, it looks like we get to pop them into our back pocket and say, once I see this little form, it's something that I can just do automatically. Looks like I can make it a rule.